Some of you may remember that in a previous video I built this 20-meter antenna using two old CB antennas. The black portion here was one CB antenna, and then this portion here was the other CB antenna, and I trimmed and tuned it to length, and it resonates on 20 meters. You may remember that it screwed directly into the antenna mount, as you see here behind me, and that's fine if you only have an antenna for a single band. But over the weekend, I bought new antennas for two more bands. I bought one for 40 meters and I bought one for 17 meters. So I want to be able to swap out the antennas quickly. So I got some quick disconnects. These are two-piece units and spring-loaded, and I want to see how it affects the tune on this antenna before I put it in. So what I'm going to do is I'm going to install the antenna without the quick disconnect, and then take measurements using the NanoVNA, and then put in the quick disconnect to see what, if any, impact it has to the resonance and SWR of the antenna. So stick with me, we'll go through it and see what it does. Okay, as you can see here, I've got the antenna screwed directly into the mount, and we're going to test it like this first, and then later we'll come back and install this to see what changes, if any, are made. Okay, I'm in the truck now, and I have the NanoVNA connected to the antenna, and we're going to take the baseline measurements of what the SWR is and the resonant frequency for this antenna before we install the quick disconnect. So let's look at the NanoVNA. Okay, we have the NanoVNA set up on the 20-meter band now. You can see that it's tuned for the lowest SWR way down here. Let's see where that is. That's approximately 14.273 megahertz is where the lowest SWR is. And if you look here, this cyan light blue marker is right on the pure resistance line. That line right there in the middle is where the antenna is giving pure resistance, not reactance, resistance. And it just so happens it's approximately the same as the lowest SWR point. Now that's not always going to be the case. For the most efficiency, you want your antenna to be resonant at your middle of your operating band, or the frequency that you want to operate on. That's where it's most efficient. SWR is just the relationship of the impedance, you know, how close it is to 50 ohms. 50 ohms is what your radio is expecting to see to prevent standing wave ratio. Here we're at 14.273, and our SWR is 1.043. And this is without the quick connect adapter. So we'll make note of these settings, and then we'll put in the quick connect adapter and see what changes. Okay, we've tested for our baseline reading before we put in the adapter. So let's go ahead and unscrew the antenna, and this is what we're going to hopefully improve upon, not having to unscrew the antenna and screw in a different antenna. We'll lay that right there. We'll get the adapter, and this should screw right in, and it does. We'll get it tight by hand. And this is both pieces of the adapter right now. I didn't break it down into two different pieces. All right, and that's screwed in. Now we can screw the antenna directly into the top part of the adapter. It's good snug fit on the threads. And once we get it down, I'll take a wrench and tighten it up. And that'll tighten both the antenna into the adapter and the adapter into the base of the antenna mount here. And we don't have to get crazy torquing it down. Just get it tight. It should be fine. Now to remove the antenna, you just press down a little bit, pull up. The antenna's off. That is nice. It allows you to do a band change in just a matter of seconds. Take off one antenna, put the other antenna on, and that's a good connection there. And the reason it's such a good connection is because in here, hopefully you can see that, there's a spring, and that keeps the connection tight. That spring right in there puts pressure on the connection and makes sure it's tight. So we'll put that back on like that, and we'll go in with the NanoVNA and check and see what the SWR and the resonant frequency is now. It should have changed, maybe just a little bit, but I think it will change because we've added, how much? 2 inches to the length. So what's that going to do? We think, at least I think, it's going to bring the resonant frequency a little bit lower than what it was. How much? Let's go check. Okay, here's the NanoVNA readings now that we've got the quick disconnect in place. And let's see what has changed, if anything, here. You notice our SWR frequency has gone down quite a lot. Let's see here. That seems to be about it there. We'll call that the low point, and that's at 14.1685. Let me write that down. 14.1685. That's our new low point for the SWR. But what about our resonant frequency? It's close, but I think it's a little bit higher there. What you want to do, this marker here has got a point on the bottom of it. And what you want to do is get that point to where it's just touching this horizontal line here, which is the resistance only line. So I'm going to try to bring that down. I got it stuck. I have to move it again. And that looks to me to be at the point where it's touching the line now, and that's 14.18. So it did lower the frequency, okay, where it's resonant. So 14.180 is the resonant frequency now. And the lowest SWR point is a little bit lower than that, somewhere in that neighborhood there. And there the SWR is reading 1.12. So the SWR changed a little bit and the resonant frequency changed a little bit. Is that going to seriously impact the performance? No. We should be able to tune the antenna to get the resonant frequency since this is a mobile antenna, okay? So primarily we're going to be running sideband on the mobile radio. So we want the resonant frequency to be more, you know, from 14.225 to 14.350. So if we get it centered somewhere around 14.23, we should be good. We'll see if we can't do that by adjusting the length of the antenna a little bit. Okay, since we're too low, because that means the antenna is too long. So we're going to need to either adjust the length of the antenna or if we have to, we can cut a little bit off the length of the antenna. So let's go see how much adjustment we have, and then we'll check it again. Okay, since we've got the quick disconnect, let's take the antenna off and see if we have any adjustment here on the whip portion of the antenna with these Allen set screws. What I need to do is mark a starting point on the whip so I'll know where it is right now. We'll use a magic marker so we can know how much we adjusted it, if we can adjust it. So let me get my Allen wrench, and then we'll loosen up these screws and see how much we can adjust it. Okay, you can see our mark on our antenna whip here, and this was all the way into the antenna, and that's about as far as it will go. So in order to tune this to a higher frequency, I'm going to have to cut off some of the antenna. So I'm going to cut off approximately 25 millimeters up here, and then we'll see how close we are. We should be able to slide to adjust it. Now this is stainless steel rod, so it's pretty strong. I'm using some vice grips with the cutter there, and it won't cut all the way through. Basically, I have to dent it pretty good, then bend it to break it. So let's see if I dented it enough. I don't think I dented it enough on that first go. It's, like I say, it's pretty strong. It's not real easily cut with wire cutters, but maybe that's got enough dent in it now where I can bend it and break it. Not yet. A little bit more. Putting it on that same spot and just tightening down on the screw a little bit more each time to close up the gap. You saw and heard that was pretty hard to close on that one, but I think this time I'll be able to bend it back and forth a little bit and break it off. So we cut off approximately an inch, 25.4 millimeters. Okay, so let's put it back down to this mark again that we marked where it was and see what the tune looks like there. So I'll just slide that back down in to the same mark, and we'll tighten up the Allen screw here to hold it in place so it won't slide on us. And then we'll see if we need to lengthen it a little bit or what in order to make it resonant with the lowest SWR. I'll lay the Allen wrench down there on the bumper. Hopefully I'll remember where it is and which one it is. Finding the right one, from what I can tell, these are metric set screws. I had to go find my metric Allen wrenches. And if you buy one of these antennas new, it's going to come with the proper size Allen wrench, so you shouldn't have to worry about that. But again, this is the monstrosity that I built, so nothing is standard. So let's go back and get on, reconnect the antenna here. Easy reconnect, and we'll go check it on the NanoVNA now. Okay, as you can see, we're way too short. I didn't need to adjust it very much, but we have a lot of adjustment with that set screw. So now I'll loosen the set screw, and let's raise the whip in the antenna about 1/2 inch. So let's go do that, and we'll see what it's doing then. Okay, we adjusted the length of the antenna approximately 1/2 inch, maybe just a little bit more. And it did change where the low SWR point is. The resonant frequency is still a little high. We're about 14.333, So let's go lengthen that just a little bit more with the set screw, and I'll raise it another 1/2 inch now, and we'll see where our resonant frequency and SWR is after that. Okay, I think we're going to call this good. You can continue tweaking if you want to, but we've got our resonant frequency here at about 14.220, which is, you know, the lower portion of the voice band on 20 meters. We've got our high SWR up here at 14,350 of approximately 1.6 something. I can go on up there and measure it. And we're at 1.636 SWR for the high. The low down here, you may have seen that earlier. I didn't look at it, but it's at 1.07, and then down here on the lower end of the band, it's 1.3. So very usable across the band. And now we've got the quick disconnect, and you know, we can take it off. See, I have to take my antenna off anytime I go into my garage. So it's just a quick, you know, 5-second get out and snap it on, and or get out and take it off. It's a lot faster than using the threads. That seems to have worked very well. Did have to make a small adjustment to the length of the antenna to move the resonant frequency where I wanted it. You can put yours where you want yours, depending on what portion of the band you're using. But for 20 meters, for me, I've got mine set where it's very workable. Would not even have to use a tuner on it right now, because, you know, it's that close. But if you wanted to, you know, get your SWR down even further, you can use a tuner. The main thing is it's resonant at that frequency of 14.122. So hope you've benefited from this, maybe learned something from it. This may be old news to you, but there's a lot of people out there where this could be useful information. Hopefully it will help you in your ham radio journey. If you liked it, please give me a thumbs up. It really helps the channel to grow when you give a thumbs up, or if you share this with your friends. Any kind of interaction with the channel helps the channel to grow, and I really appreciate it. If you'd like to contribute to the channel to help support the equipment, the time and effort that's put into these videos, you can buy me a coffee in the link down in the description, or I'm sure I put the QR code somewhere in this video where you can take a picture of that with your camera, and it'll take you directly to the buy me a coffee link. Any support is appreciated. This is Jerry, Kilo Mike 4, Zulu Kilo Bravo. Hope you have a blessed day.